Hello friends and welcome to CFEDU Vlog. My name is Neil and I will be your guide on mathematics. Now today we'll be starting with a general introduction to mathematics. Now I know that mathematics is a term that we are used to, it's something that we've been hearing, but what is mathematics? Now mathematics is that aspect of our lives that involves the use and manipulation of numbers. Whatever we do in life, whereby we manipulate numbers, now we are doing mathematics. For example, we trade, we buy and sell using numbers, right? Basically, that is applying mathematics. Another example is when we share things with our friends, family, and loved ones. Now, that is mathematics because here we are manipulating numbers and digits. So everything that we do in life that involves numbers is known as mathematics. Now, these numbers we talk about in mathematics, they are arranged serially and at an equal interval on an imaginary line known as number line. So what is a number line? So remember, we said that it is an imaginary line. So let's see what it looks like. Let's assume that this is a number line. Our number line possesses a neutral point known as its 0 point, or simply known as 0. Towards the right hand side of our number line is where we find our positive numbers. So we have 1, 2, 3. Now down to positive infinity. So this is positive. And towards the left-hand side of our number line, you see we'll get our negative numbers. And here we'll find -1, -2, -3, down to negative infinity. Now, please let us remember that now these numbers are arranged at equal intervals. Every number that falls or that we can find on our number line is known as real numbers. Okay, now on our number line we find two categories of numbers. Or can say we have two categories of real numbers. The first one is the one we know as integers. So what are integers? Integers are the whole numbers we find on our number line. Now be it negative, be it positive. For example, now -3 is a whole number, -2 is a whole number, 2 is a whole number, 4 is a whole number. All these whole numbers are generally referred to as integers. So under integers, we still have three different classes of integers. Now the first class we'll be looking at will be the class of even integer numbers. Or simply even numbers. So what are these even integer numbers? Now we can simply define even integer numbers as numbers that can be divided by 2. Or we can say that even integer numbers are gotten when we take a leap of 2 intervals from our origin. What do I mean by that? If I decide to take a leap from this my origin point of 2 intervals, 1, 2, my landing point will definitely be on an even number. If I decide to take another leap from this my landing number, 1, 2, whatever I land on will be an even integer number. Now, and the same is applicable towards the negative side of our number line. So the next integer numbers we'll be looking at will be the odd integer numbers. So what are odd integer numbers or simply odd numbers? Odd numbers or odd integer numbers are those integer numbers that are not even integer numbers. Every integer number outside the even integer number is known as the odd integer number. And the examples are here we have 1, we have 3. Now we have -1, we have -3, we have -5, we have 5, we have 9, we have 11. All these numbers are known as odd integer numbers. And the last class is what we know as prime integer numbers. So what are prime integer numbers? Prime integer numbers are those numbers that can only be divided by 1 and itself. Prime integer numbers are those integer numbers that can only be divided by 1 and itself. An example of that is, now we have 2, we have 3, we have 5, we have 7. Alright? Now I want us to note this. jumped, I skipped one when I was giving us an example of prime numbers. And that was not a mistake. 1 is not a prime number. And every negative number is also not a prime number. So you can get your prime numbers only towards the positive side of your number line. And the next form of numbers we can find on our number line are the numbers known as our decimal numbers. There are numbers known as our decimal numbers. Our decimal numbers. So what are decimal numbers? Decimal numbers are those numbers that can be found in between two integers. There are those numbers that can be found in between two integers. And these decimal numbers, they range from 1 to 9. So it means that now from here to here is an integer. From here to here is an integer. So from here, I have minute numbers that range from 1 to 9 that are known as negative numbers. So if I decide to pick a number here, let's say this is my minute 5. If I decide to pick a number here, I'll end up picking a decimal number, sorry. Now how do we denote a decimal number? Now a decimal number comes before a decimal point. For example, if I pick at this point, now I picked at minute number 2, right? That comes before 0. So this number will be 0.5. Now if I decide to pick a number also here, and the minute number that falls here is, let's say, 2. Okay? Now this number that I will pick here will become a decimal number. And the decimal number will be written as 1.2. Now, if you look at the order of my writing this decimal number, you find out that now, in writing a decimal number, your integer number will come first before your decimal point. All right. So, in our number line, we find two classes of numbers. The first one is the ones we refer to as our integers, and the second one is the ones we refer to as our decimal numbers. All right. So let's continue. Now remember, this is just a general review or overview of what mathematics or the numbers we use in mathematics is all about. Okay? So basically, let's see the place values of these decimal numbers we just talked about. Let's see the place values of these decimal numbers we just talked about. All right? Now, for example, let's assume we have a number like 67,193.542. Okay? Now this is 67,193.542. Now this is a decimal number because of these decimal points we have here. Alright? So let's see the place values. Now we see that the first number that comes before our decimal point. Now what I mean, if I mean to the left of our decimal point, its place value is the unit position. The unit position. So we have that 3 occupies our unit position. And the number that comes before 3 occupies the 10th position, So we have that 9 occupies the 10th position. And the number that comes before 9, immediately before 9, occupies the 100th position. So we have that 1 occupies the 100th position. And the number that comes before the 100th position is the 1000th position. So you have that 7 occupies the 1000th position. And the position that comes before the 1000th position is known as the 10,000th position, which means that 6 occupies the 10,000th position. So we have 10,000. So now that is it for our whole number part. Now let's move over to our decimal part. On our decimal part, the number that comes immediately after our decimal point, the position is known as the 10th position. So it means that 5 occupies the 10th position. The 10th position. And the position that comes immediately after the 10th position is known as the 100th position. And it means that 4 occupies the 100th position. And the position that comes immediately after the 100th position is known as the 1000th position, which invariably means that 2 occupies the 1000th position. So we have that 2 occupies the 1000th position, and so on and so forth. Now, whatever the position that comes after the 1000th is the 10,000th, and after the 10,000th we get the millionth, all right, and so on and so forth. And the same thing is applicable to this other side. So we can have that. Now, 3 units means just 3. 3 tenths. Okay, 9 occupying the 10th position means it is 9 tenths, which is 9 times 10, which is 9 tenths. Now, this is the 100th position, and I have 1 occupying the 100th position. So this is 1 by 100, which will give us 100. Now, and this, we said that 7 occupies the 1000th position. So this is invariably 7,000. So which is equal to 7,000. This 6 occupies the 10,000 position. So I'll have 6 times 10,000, which will give us the 60,000. Now, and to the 10th. Tenths is written as just a position before our decimal point. So 5. This is 0. So this is 0.5. Now, the 100th is 2 positions after our decimal point, and 4. The 4 is occupying that position. So I'll have 0 point. Now I'll fill up my first position with 0 before I land to the position being occupied by 4. Now this is the 1000th position. So I'll have 0 points. I have 2 positions before the 1000th, and I'll fill those positions with 0, sorry. So I'll have 0, 0, and then 2. So this, if I should sum these things together, I will get back exactly this number that I have here. So when we talk about the place values of decimal numbers, this is basically what we are making reference to. Now the next thing we'll be looking at will be decimal fractions. What are decimal fractions? Now, before we go into decimal fractions, I would like us to note that every decimal number contains a fraction. Let me show you what I mean. Okay? Now, just like I said earlier, every decimal number contains a fraction. But how do we pick out, or how do we reveal the fractions in every decimal number? For example, if we have something like 2.55, there is this. This is a decimal number, but this decimal number possesses a fraction known as decimal fractions. So how do I pick out my fraction here? Now we do it by now this part is my decimal part, right? So I will rule a line across my decimal parts to have 2.555. Then I'll rule a line. My decimal point, under it I will fill it up with 1. Then every other number that comes it will be filled up with 0. So we have that 2.55 is equal to 255 all over 100. Now this is 2 whole number, this is 2 integer, 55 all over 100. So this is the decimal part of this fraction. Now the same thing is applicable when you have something like 34.5789. This is a decimal number, right? Inside this decimal number, it possesses a decimal fraction. So how do we reveal the fraction the fraction of this decimal number? Now, just like what we did here before, I'll come to my decimal part and rule a line. All right? Then underneath my decimal point, I'll fill it up with 1. Then every other number that comes will be filled up with 0. So under 5, I'll fill up with 0. Under 7, I'll fill up with 0. Under 8, I'll fill up with 0. And under 9, I'll fill up with 0. To have that 34.5789 is equal to 34 whole number, or 34 integer, 5789 all over. Now this is 10,000. 1, 10, 1, 2, 3. So basically that is it on decimal fractions. Alright? Every decimal number is also a decimal fraction. Alright, now basically let's see the application of the basic mathematical operations on the values we have on our number line. Alright, let's see the application of basic mathematical operations on the numbers on our number line. Now the basic operations we have in mathematics, they are addition and subtraction, multiplication and division. So let's see how this can be applied to numbers. The first set of mathematical operations we'll be looking at will be addition and subtraction. But I'll start with addition. So what does addition mean? Addition means to increase a number by another number, or to increase a unit by another unit. For example, if we have 2 plus 5 equal to. Now, how do we apply addition to this on our number line? So let's draw a number line. Now, this is our neutral point 0. I'll have 1, 2, 3, 4, 5, 6, 7, 8. Now, so on and so forth. 2. So I will count 2 from my point of origin. I'll have 1, 2. Plus 5, which means increase it by 5. So I'll add extra 5. 1, 2, 3, 4, 5. Now that will drop me on number 7. So which means that 2 plus 7 will give me 7. Now the same is applicable if I have minus 3 plus 8. Now this is minus 3. So where is minus 3 on our number line? I'll have minus 1, minus 2, minus 3, so on and so forth. So minus 3 increased by 8. Now this is minus 3, right? Then I'll add extra 8 to it. So I'll have, okay, let's hit our minus 3 first from our neutral point. So this is our neutral point, right? Minus 3 will hit 1, 2, 3. Now, plus 8 means to increase it by 8. So it will have to move forward. 1, 2, 3, 4, 5, 6, 7, 8. And that will drop me out at 5. So it means that minus 3 plus 8 is equal to 5. Okay? Now these additions we did, they are additions on integers. Now we also do additions on decimal numbers. And they are done exactly the same way we do them on integers. Now let's solve an example. Let's solve another example involving integers, involving them decimal numbers. Let's say you have 12.21 plus 10.11. Alright. Now, they need us to add. Now, from our number line, 1 plus 1 will give us 2. Now, 2 plus 1 will give us 3. Then decimal point, 2 plus 0 will give us 2, and 1 plus 1 will still give us 2. So this is basically what we have. Now the next thing we'll be looking at will be subtraction. Subtraction. What does subtraction mean? Subtraction. Subtraction simply means to decrease or to reduce a number by another number, or to reduce a unit by another unit. What do I mean by that? If I have 5 minus 3 is equal to, now on our number line, we have our 0 points, 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5, so on and so forth. Now this is 5 decreased by 3. So I'll first of all count my 5. 1, 2, 3, 4, 5, right? Now decreased by 3 means I will step backwards 3 times. So I'll move back 1, 2, 3, and I will land on 2. So 5 decreased by 3 is equal to 2. Alright? And now that is basically what subtraction is all about. Now let's look at multiplication. So the next form of operations we'll be looking at will be multiplication and division. So let's look at multiplication. What is multiplication? Now the multiplication of a number by another number simply means increasing the first number by itself onto the number of times of the second number. Now what do I mean by that? Please do not be confused. If we have something like 2 times 3. Now this simply means increasing 2 by itself 3 places, which is equal to 1, 2, my first 2, 1, 2, my second 2, 1, 2, my third 2. So if I should bring these 3 2's together, I'll have 1, 2, 3, 4, 5, 6, which will give me 6. Okay? If I have 3 times 4. Now this means increasing 3 by itself 4 places. Now this will be equal to 1, 2, 3. My first 3, 1, 2, 3. My second 3, 1, 2, 3. My third 3, 1, 2, 3. My fourth 3. So if I should bring these 3's together, I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will give me 12. Alright? So basically that is what multiplication is all about. Now, but what about the multiplication of decimal places or decimal numbers? Now remember, these things we did here, they involve only integers. Now, how do you multiply your decimal numbers? So let's look at multiplication under decimal numbers or multiplication of decimal numbers. So basically, let's see multiplication of decimal numbers. Now, these things we did here, they are multiplication of integers. But how do we multiply decimal numbers? So for example, if you have 2.3 times 2.5. Now this is a decimal number, this is a decimal number. Now how do I multiply? Now the thing is, I will pick one of the numbers and use every element or every digit in that number to multiply every digit in the other number. What do I mean by that? I'll have 2.3 times 2.5. So I will use every digit or every number in 2.5 to multiply every number in 2.3. So, and I'll start with the last. Now here I have 5 to be the last, so I'll start with this. 5 multiplied 3 or multiplied by 3 will give us 15. Right? Now because this is base 10, I'll write 5 and carry 1. Now 5 times 2 is 10. 10 plus 1 is 11. Now I'm done with this very particular number. I'll move to the next number. 2 times 3 is 6. Now I'll put it under the position of that number I'm working with. So I'll put 6 here. Now 2 times 2 is 4. So that I can have so that I can have 1, 1, 5, then 4, 6. I will sum them together to have 5, 7, 5. Now, but in my first number contains just one decimal place. My second number contains another one decimal place. If I should combine the two decimal places, I will have a total number of 2 decimal places. So if I want to leave my answer, I will leave my answer in 2 decimal places, which means that I will put my decimal point before 2 numbers to the last to have 5.75. Okay? And another example, for example, if we have 1.56 times 3.52. Alright, now it is basically the same thing we do. So I'll use every digit here to multiply every digit here. So I'll start with the last, which is 2. Now 2 times 6 is 12. I'll write 2, carry 1. 2 times 5 is 10, plus 1, 11. I'll write 1, carry 1. 2 times 1 is 2 plus 1, 3. 2 times 2 is 4. Then I'll move to the next number. 2 times 3 is 6, is 30. 5 times 6, is 30. So now I'll start writing under the number I am multiplying with. So I'll write my 0 here, then carry my 3. 5 times 5 is 25. 25 plus 3 will give us 28. So I'll write 8 and carry 2. 5 times 1 is 5, plus 2, 7. And 5 times 2 is 10. So I'll write my 10. So I'm done with 5 and 2 there. So I'll move to 3. 3 times 6 is 18. Remember, I'll start on that number I'm working with. So I'll write 8, carry 1. 3 times 5 is 15, plus 1, 16. I'll write 6 and carry 1. 3 times 1 is 3 plus 1, 4. 2 times 3 is 6. So I'll write 6. So I will now add them together, and I'll fill up my vacant spaces to 0. 2 plus 0 will give us 2, plus 0 will still give us 2. 1 plus 0, 1 plus 0, 1. 3 plus 8 will give us 11. 11 plus 8 will give us 19. So we'll write 9 and carry 1 across. 1 plus 4 will give us 5. 5 plus 7 will give us 12. 12 plus 6 will give us 18. We'll write 8, carry 1. 1 plus 0 will give us 1, plus 4 will give us 5. 1 plus 6 will give us 7. Now, this is it. Now, but we are not yet done. we need to place our decimal, we need to find our decimal place. Our first number has 2 decimal places, 1, 2. Our second number has another 2 decimal places, 1, 2. So it means invariably that our answer will have 4 decimal places. Now, so I'll start counting my decimal places from the last digit. So I'll count 1, 2, 3, 4. So I'll place my decimal point here. All right? To have our answer to be 75 plus 8, 9, 1, 2. All right. Now, basically, that is it on multiplication of decimal numbers. Now, let's see the application of division to number. What does division mean? Division means to share among. Now, another term for division is inverse multiplication. All right? So, if you have something like 6 divided by 2, now this invariably means divide 6 amongst 2. So, I'll have 1, 2, I have 2 sharing 6. 1, 2, 3, 4, 5, 6. So, I'll have 3 complete pairs. So, my answer is 3. You can have something like 9 divided by 3. So, this is share 9 amongst 3. So, I'll have 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, I have the complete sets I have is 1, 2, 3. So, I have 3 complete sets. So, my answer will become 3. Now, I can also have 9 divided by 4. Now, what will it give us? So, I'll write out 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you look closely at what we have here, I have 2 complete sets and then 1 stranded set. So, my answer will be 2, remainder 1, or 2, 1 out of 4. So basically, that is what division is all about, all right? Now, the next thing we'll be looking at, factors and multiples of a number. So what are the factors of a number? The factors of any number can be defined as all those numbers that can divide that number without leaving a remainder. So we have that factors of a number are all those numbers that can divide that number without leaving a remainder. And for examples, if we have a number like 4, all right, the factors of 4, let's say F4, there are numbers that can divide 4 without giving us a remainder. And all those numbers are, we have 2, we have 4. So now 4 divided by 2 will give us 2. 4 divided by 4 will give us 1. And 4 divided by 1 will still give us 4. So 1 can also be termed the factor of a number. Now another is, let's talk about 9. The factors of 9. Now these are numbers that can divide 9 without a remainder. So we'll have 1. 1 divided 9 will give us 9, no remainder. Now 9 divided by 3 will give us 3 and no remainder. Now 9 divided by 9 will give us 1 and no remainder. Okay? So the factors of a number, just like we said, numbers that can divide that number without any remainder. So let's look at the multiples of a number. The multiples of a number can be defined as those numbers that number can divide without leaving a remainder. So we have the multiples. So we have that the multiples of any number are all those numbers that can be divided by that number without leaving a remainder. So for example, if we have a number like, now I will not use 2 because the multiples of 2 are that to infinity. Okay, now the multiples of most numbers are to infinity. So let's look at a number like 3. Okay, the multiples of 3, let's say M3, can be, what are numbers that can be divided by 3? 3 can be divided by 3, 6 can be divided by 3, 9 can be divided by 3, 12 can be divided by 3, 15, and so on and so forth. Now, all these numbers that can be divided by 3 without giving us a remainder, that number is known as the multiples of that number. Another example is 4. Multiples of 4, M4. They are 4 can divide itself. 8, we have 12, we have 16, we have 20, and so on and so forth. Now, if you look at these, now these numbers that 4 can divide without giving us a remainder, without leaving a remainder. And numbers like this are known as the multiples of 4. Alright? So basically that is it for multiples, factors, and multiples. Now let's look at highest common factors and lowest common multiples. Highest common factors and lowest common multiples. So let's see highest common factors, popularly known as HCF. Now what is HCF? Now basically you use HCF when you are comparing the factors of 2 or more numbers. And just like the name says, it is highest common. Alright? So if you are comparing the factors of 2 or more numbers, you are looking for the highest that is common amongst the factors of those numbers. For example, if I'm looking for the HCF of, let's say, 8, 12, and 16. Alright? Now, what are the factors of 8? Remember what we said that factors are. We have F8. F8 are, we have 2, we have 4, we have 1, we have 8, right? Now, the factors of 12, let's say F12. We have 1, we have 2, we have 3, we have 4, we have 6, and we have 12. The next to be factors of 16. Let's say F16. We have 1, we have 2, we have 4, we have 8, and we have 16. Now remember, it is highest common factors. So we'll pick out the factors common to these numbers. Now what are the factors common to them? Now we have 1 common. Now we have 2 common, right? Now we have 3 common. Now what else do we have? Okay, we don't have any other common factor. Now, but we're not just looking for common factors. Now we are looking for the highest amongst them. Now, and the common factors we have is 1, 2, and 4. Now, which one is the highest? It is definitely 4, right? So the HCF of 8, 12, and 16 is equal to 4. Alright? Now, another means of finding this without going through this rigorous process is by our long division method. Now, what do I mean by long division? We'll divide them simultaneously. We'll have 8, we'll have 12, we'll have 16. So I'll pick the number that is common, the factor that is common to every number here. I'll have 2. This will give me 4. This will give me 6. This will give me 8. We'll have 2. This will give me 2. This will give me 3. This will give me 4. Now look at the numbers we have here. Now, we don't have any factor. Now, we have 2 here. We have 3 here. We have 4 here. Now, there is no factor that is common to 2, 3, and 4. So, I will stop here. To have my HCF to be equal to 2 times 2 to still give me. So, I'll have my HCF to be equal to 2 times 2, which will still give me 4. Now, basically, that is the principle of HCF. Now let's look at LCM, lowest common multiples. Lowest common multiples. And just like in HCF, now we apply LCM when we are comparing the multiples of 2 or more numbers. Now we'll work with an example to make it clearer to us. Now let's seek for the LCM of 3, 6, and 8. So let's see the multiples of 3. Now I hope you remember what multiples are of 3. So the first multiple of 3 is itself. The next multiple we'll be looking at will be 6. After 6, we'll find 9. After 9, we'll find 12. After 12, we have 15. After 15, we have 18. After 18, we have 21. After 21, we have 24. After 24, we have 27, we have 30, and so on and so forth. Now let's look at the multiples of 6. M6. What are the multiples of 6? The first multiple of 6 is itself. 6, we have 12, we have 18, we have 24, we have 30, we have 36, and so on and so forth. Now let's look at 8. The multiples of 8. We have 8 itself, we have 16, next, we have 24, next, we have 32, next, we have 40, next, we have 48, and so on and so forth. Now remember, we are looking for lowest common multiples. So we look for the multiples that are common amongst these numbers. Now what are the multiples we have now that are common? No, not common. No, not common. 12. No, not common. 15. No, not common. 18. No, not common. 21. No, not common. 24. Yes? So the first common multiple we have is 24. Now what is the next common multiple? Now the next common multiple is when we start extending. Now but remember, we're looking for the lowest. So whatever multiple we get after this, they will definitely be higher than 24. So the lowest common multiple of 3, 6, and 8 is equal to 24. So we have their LCM to be equal to 24. Alright? Now, and another easy way of doing this is by following our long division method if you want to go through this rigorous process. Now, how do we do it via our long division method? Okay? I have 3, I have 6, I have 8. So I'll divide. I'll have 3 divide 3, 1, 3 divide this is 2. Can 3 divide 8? No, so I'll bring down to 8. Remember, we're dealing with multiples, okay? So that is why we don't care about if it can divide or not. Now, the next thing we have is 2. I have 1, I have 1, I have 4. So I can pick 4 straight, then 1, 1, 1. So to have my LCM to be equal to 3 times 2 times 4. Now, 2 times 3 is 6 times 4. It will still give us 24. So to have our LCM to be equal to 24. Alright, so basically that is what LCM and HCF is all about. Now let's look at what we refer to as significant figures. Next up for us will be significant figures. So what are significant figures? Just like the name applies, significant. Significant figures are those digits in a number that are of importance. What do I mean by that are of importance? I mean those digits of a number that add value to that very particular number. Let's take for example, if I have 0, 0, 0, 0, 1, 1, 0. Now what is this term being pronounced as? This is 110. Alright? Now I hope you know that 110 is also being pronounced as 110. Now what we still pronounce it as 110 because these 4 zeros that comes before this 110 does not add any value to the 110. So this is still 110, this is still 110. Alright? Now but look at this. 1, 2, 3, 4, 5. This is 100,000. And why is it being pronounced as 100,000? Now it is being pronounced as 100,000 because the value of these zeros that comes before the 1 is being recognized. Alright? So here, zeros here are significant. Here, the zeros here are not significant. Another good example is when you have something like 0.0011. Alright? Now, in this number, these zeros are not significant values. They don't add any value to what we have here. Now, but look at this. 0.1001. if you look at these numbers, now these zeros are of great importance to this number. Okay, so the zeros here can be termed as significant figures, while the zeros here can be termed as non-significant figures. So what did you say as significant figures are? Significant figures are those digits of a number that add value or that give significance to that very particular number. So let's look at the basic rules. So let's look at the basic rules of significant figures. Now these are the rules that helps us determine where the significant figure where the significant figures of a number starts from. So the first rule tells us that the first significant figure is just the first number that is not 0. And I think that this first rule was explained when we were trying to define what significant figures mean. And now the second rule tells us that all other numbers after this are significant even if they are 0. So let's work with examples. So let's look at this. 0.003011. Alright? Now if we look at what we have here, from our first rule it tells us that our first significant figure starts from 3. Now the second rule tells us that once we meet our first significant figure, every other figure that comes after it is significant. What does it mean? It means that once we've gotten our first significant figure, now this becomes significant, this becomes significant, this becomes significant. Even if I have 0.00300012, okay? Once I encounter my first significant figure, which definitely should be a non-zero number, now whatever I have after it becomes significant. So it means that in this number, once I've encountered this with my first significant figure, these zeros are significant. Okay? Now let's look at the third rule. After rounding off, fill in with zeros but not beyond the decimal point. Now this rule is applicable to our whole numbers. What do I mean by whole numbers? If I have 2, 7, 8, 9, 5, okay, and I'm asked to round off to 3 significant figures. Now, our first significant figure starts from the first value we have. So we'll count 3. 1, 2, 3. Okay? Now this is 9. It is greater than 5, so we approximate and add to our third place to have 2, 7, 9. Now, but our third rule tells us that I will not just stop at 279. Alright? Now remember, in this number, our decimal point is here. So it means that after the third digit, I'll still have 2 positions before my decimal point. So I'll fill up these 2 positions with 0, then before my decimal point. So that is basically what this rule is all about. The next on our list will be the reciprocals or inverse of a number. The reciprocal or the inverse of any number is that number with which if I multiply the number, I will have 1. What do I mean by that? If you're asked to find the reciprocal of, let's say, A, what I'm simply asking you to find is that number with which I will multiply A to have 1 as my answer. Alright? So basically, if this is what we are looking for, if this is what we are looking for, then we'll divide both sides by A to have that whatever we are looking for is 1 over A. So this invariably tells us that the reciprocal of or the inverse of any number is 1 over that number. So if you have 5 and they say you should find the reciprocal, it is equal to 1 over 5. If you have 10, its reciprocal is equal to 1 over 10. If you have 20, its reciprocal is equal to 1 over 20. Alright? So the next thing for us to do is multiplications and divisions involving 10 and its multiples. So we all know that 10. Now this is 10. To get the multiples of 10, all we need to do is just to keep increasing the number of zeros we have. So the first multiple of 10 is now 10 plus an extra 0. The second multiple of 10 is 10 plus 2 zeros. The third multiple of 10 is 10 plus 3 zeros, and so on and so forth. So how do we do multiplications that involves 10 and its multiples? Now it is very, very simple. In fact, it is the easiest multiplication or division to do in mathematics. So for example, if I have 2 and I am multiplying 2 by 10. Now I hope you know that 2 as being a whole number does not mean that it does not possess any decimal point. But we are ignoring its decimal point because there is no valid number that comes after the decimal point. But this is 2.0 times 10. Alright? So multiplying by 10 means to move my decimal point forward just a place. What does that mean? It means multiplying this by 10 means I should move my decimal point just once to have 20. Now if I have 2.0 and I'm multiplying by 100, what does it mean? It means I should move my decimal point 2 places from its position. So these 2 places means 2.0, then I'll move 1, 2, then drop it and fill up this void with 0 to have this to be 200. Now if I have 2 multiply by, let's say, 1000, remember this is 2.0 times 1000. What does it mean? It means I should move this decimal point 3 places ahead. So ahead means 2.123. Then I'll drop my decimal point and fill up this void with 0. To have that 2.0 times 1000 is equal to 2000. So what does this mean? This means that whenever we are multiplying any number by 10 or its multiples, the solution is just to move our decimal point by the number of zeros we have. Now let's look at division by 10 and its multiples. Now it's just like what we have in multiplication. If I have 2 divided by 10, or better still 2 over 10. Now remember what we said. I have a decimal point here. Alright? Now when we were multiplying, we are moving our decimal point forward. Now but division means we should move our decimal points backwards. So dividing by 10 means I should move my decimal point backwards just once. So I'll move it backwards to drop it here. To have 2 over 10 to be 0.2. So if I'm dividing 2 by 100, 2 divided by 100. Now this is the same thing as 2 all over 100. Now I have my decimal point here. Now 100 means we have 2 zeros here, so it means I should move it backwards two times. So I'll have 1, 2, then drop my decimal points, fill up with 0. To have this to be 0.02. If I'm dividing by 1000, let's say 2 divided by 1000. This is the same thing as 2 over 1000, right? So now this is where my decimal point is. 3 zeros means I should move backwards 3 places. So I'll have 1, 2, 3, drop, then fill up with 0. To have that 2 divided by 1000 is equal to 0.2000, then 2. Okay? So basically now this is the technique used in the multiplication and division involving 10 and its multiples. Now BODMAS is what gives us the hierarchy of the basic operations in mathematics. So now BODMAS B simply stands for bracket. O simply stands for off or order. Now D simply stands for division. M simply stands for multiplication. A simply stands for addition. And S simply stands for subtraction. So if you look at what we have on the board, now this contains the basic operations we talked about in mathematics. Okay, so this tells us that if I encounter any problem, any question in mathematics that involves many mathematical signs or operations, now the first thing to do is I will tackle where the questions where that it means that I will tackle questions where I have a bracket. After which I will go to the off. After off, I do the division part of the question, then multiplication part of the question, addition and subtraction part of the questions. So let's do examples. If I have 5 minus 3 times 2, alright? The basic mathematical operations we have is minus and multiplication. Now, but if you look carefully, if you look closely at this, you'll find out that we have a set of numbers that are included in a bracket. Now, this bracket shows urgency. So it means that we are supposed to tackle whatever we have in the bracket first. So we'll have to do 5 minus 3 first, which will give us 2. And I'll have 2 times 2 to have our final answer to be 4. So also, if I have 5 plus 3 times 2. Now look at this. 5 plus 3 times 2. No brackets, right? I have plus. Now the signs I have here are plus and multiplication. So I'll simply move over to BODMAS. Now what does BODMAS tell me? BODMAS tells me that my multiplication comes before addition. So it means that I will have to multiply this first before I add. So I'll have 5 plus 2 times 3 is 6, which will give us 11. So if I have 5 of 3 plus 2, alright? Now off is the off operation is the same thing with the multiplication operation. So this invariably is 5 times 3 plus 2. Now this is 15 plus 2, which will give us 17. Alright, now that will be it on our introduction to mathematics. Now if you love this video, or if you feel that this video has impacted you positively, now why not share with your friends, or you like and subscribe to our channel. So for further details, we have subsequent videos coming up for you.